Let's continue talking about power series, but here in this video, we're going to focusing on the function part. So the first thing first, the power series is actually coming from the power situations or the power series. So a power series like summation n equal to 0 to infinity of x to the nth power. This one, if we expand it, is going to be 1 plus x squared plus x cubed and keep adding. And we can also treat this one as a geometric series. So we can also write it as 1 over 1 minus x, where a is your 1, and then your radius, the ratio r is the x. So in order for this one to be convergent and able to rewrite as 1 over 1 minus x, we have to make sure that the absolute of x is less than 1. So this is the first one. The first concept we will use to find the power series representation of a function. So the first example we have is we want to find a power series representation of a function, or for the function 1 over x plus 2. So in order for us to using this concept to find the power series representation, we have to matching this 1 over x plus 2 into 1 over 1 minus x. So how are we going to matching them? So 1 over, let's rewrite as 2 plus x. I do not like 2, I want 1, so I'm going to factor out the 2. And of course the 2 is not really important, so we're going to keep the 2 out. And I want 1 minus x, so I'm going to do 1 minus a negative x over 2. Then I know the x portion is going to be the negative x over 2. So I got 1/2 multiplied by the summation n equal to 0 to infinity of the negative x over 2 to the nth power. In other words, I can even break it down. 1/2 times the infinity n equal to 0 to infinity of a negative 1 to the nth power, and then I have a 2 to the nth power, and then I have a x to the nth power. Then the 2 to the nth power and then the 1/2 in the front can be combined together to 2 to the n plus 1's power. And because this series is coming from here, so we know that this x, the absolute value of the x has to be less than 1. For this case, the absolute value of the x is going to be this negative x over 2. So the absolute value of negative x over 2 has to be less than 1. Then we can solve it to get that x has to be less than 2. So the interval convergent is going to be from negative 2 to 2. So here is the function, here is the power series, and here is the interval convergence. Now on Canvas, we also talk about the derivative and the integral for the power series or the function. So let's do another example using that concept. So the second example I have is I want to find a power series representation for the function ln of 1 plus x, and then we also need to find its radius of convergence. So the difference between number 2 and number 1 is we do not have 1 over something, like kind of matches to 1 over 1 minus x. Instead, we have ln of 1 plus x. But we do know that this one, the derivative, is 1 over 1 plus x. So we can work on its derivative first. But we still need to rewrite it in terms of 1 minus negative x. Which is going to be a power series let me write it here, which is going to be a power series 1 minus x plus x squared minus x cubed, or summation n equal to 0 to infinity of negative x to the nth power. And we still need the absolute value of negative x, which is the same as absolute value of x is less than 1. Okay, so we use the power series here. But I do not need everything, so I'm going to erase this power series portions because I will need this expanded form. Okay, so I'm able to write a power series representation for the derivative, but I want the original function. So what I need to do is I need to integrate it. So when I integrate the both sides, then what I have is going to be the integrating 1 over 1 plus x dx, which is the original function, ln of 1 plus x. I do not like the look, so I'm going to reorganize my work a little bit. Okay, so f prime of x, which is going to be 1 over 1 plus x, which is 1 over 1 minus negative which is 1 over 1 minus negative x, which is 1 minus x plus x squared minus x cubed plus. So what I need to do is I'm going to integrate everything. And then I will write down ln of x, 1 plus x, which is the integral of 1 over 1 plus x dx, which is the integral of 1 minus x plus x squared minus x cubed plus dx, which this side we can find is antiderivative using the power rule x minus x squared over 2 plus x cubed over 3 minus x to the 4th over 4 plus which is the summation of n equal to 1 to infinity of negative 1 to the n minus 1's power times x to the n over n plus the c. So putting everything together, ln of 1 plus x is going to be equal to x minus x squared over 2 plus x cubed over 3 minus x to the 4th over 4. This is the expanded form. In the more condensed series form, is going to be the summation n equal to 1 to infinity, negative 1 to the n minus 1 x to the n over n, with the radius x has to be less than 1. And then the radius is going to be 1.